Reading the article on page 2 and 3 of your Learning Target 17 packet about groundwater and the types of aquifers, confined and unconfined. So as we read, we're going to make sure to highlight text that helps explain similarities and differences between confined and unconfined aquifers, as well as paraphrasing key ideas, making connections, and writing questions and Google comments. Groundwater basics. Aquifers are geological formations that can store, transmit, and yield water to a well or a spring. Aquifers are remarkably diverse in geological structure. The amount of water they store, the amount of water taken from them that can be replenished, and the rate at which water moves through the aquifer. There are two basic types of aquifers, confined and unconfined. The two kinds of aquifers respond differently to pumping. Okay, let's highlight that. Refer to figure 1 below as you read about each type of aquifer. All right. An unconfined aquifer is a layer of water that has a confining layer, usually rock, on the bottom, which is in that like brownish color right here, and a layer of permeable soil above it. Remember, permeable just means able to allow gas and liquid to run through it. The recharge area is all of the land above an unconfined aquifer. So generally, water percolates or filters from the ground surface to or through an aquifer's recharge area, right here. Surface water may come from the rain or other precipitation. The water enters the aquifer by percolating down from the soil surface or through the impermeable soil in the stream or riverbed. I'm just going to highlight that. The rate at which an aquifer recharges varies greatly depending on the size of the soil and rocks that are on and under the ground surface. Highlight that. Recharge also depends on the amount of rainfall and other precipitation in or near that area. When a well is drilled into an unconfined aquifer, the water has to be pumped out, which requires energy. So the water table will rise or fall in response to the recharge and pumping. For example, the Ogallala Aquifer is a huge aquifer underlying most of the Texas High Plains, yet it has limited recharge because of the area's lower amount of rainfall and the clay soils. Remember, clay is not very permeable. Water can't infiltrate it very easily because those the grain size is so small, right? If you remember from our soil unit. The Ogallala Aquifer has also been exposed to overpumping, so the rate of recharge is not actually able to make up for the rate of pumping. Figure 2 to the left shows the changes in the water table of the Ogallala Aquifer from the period before the aquifer was tapped to for pumping in 2015, my bad. A confined aquifer is basically a layer of water that's under pressure and held between two layers of clay or impermeable surfaces. So let's highlight that and let's go back to that figure. All right, so if we see the confined aquifer, we see that's this second one on the bottom, that blue thing, right? And we see that there's a layer of rock underneath it and on top of it, or impermeable rock or soil. The recharge area is limited to the land surface where the aquifer's geologic material is exposed to the land surface. And because the recharge area is limited, the rate of recharge is much slower than unconfined aquifers. That's important, we should highlight that. Confined aquifers may be recharged by rain or stream water infiltrating the rock at some considerable distance away from the confined aquifer. Groundwater in these aquifers can sometimes be thousands of years old. And when a well is drilled into a confined aquifer, the water that's under pressure in it will rise in the well in the well casing and reach the surface without any additional pumping or energy requirements. So wells with water flowing to the surface are often called free-flowing artesian wells.